Okay, we are recording.
Awesome. Yes, thanks for having me. Yeah, so this is a reworked version of the presentation I did at Summit, back in April already. So we're looking at optimizing PowerShell for speed. As for who I am, I'm Josh King. You can find me on Twitter at Windows and VMware. And I've got a blog at king.geek.nz. So as has been mentioned, I'm from New Zealand, a little country down the other side of the world. I'm from a little town on the east coast called Hastings, and I work for the local council. So by New Zealand standards, it's a small city. But yeah, I think by American standards, we're a very small town. But yeah, so on to the topic of tonight. We're talking speed and PowerShell. Unfortunately, PowerShell over the years has had a bit of a bad rap for its speed, especially from people coming from quote-unquote real programming language like C#, and a lot of it does come down to that initial startup time. Because frankly, if you get a bad first impression, yeah, it's going to taint your impression. And it seems to be a pretty common complaint. So this was a screenshot from Google back in April. And of course, the results are, there's more now. But how we're going to measure performance tonight is we're going to use something akin to A/B testing, and I'll be frank, I'm bastardizing that term a little bit. So the crux of it all is if you're looking for improvements, you've got to measure it. Yeah, if you don't measure it, you don't know if what you're doing's had an impact, and then what's the point? As with anything in IT, make one change at a time. It's I come from an infrastructure background, so I mean, for us, if we were having a network issue, we wouldn't go and replace the patch lead, the network card, the switch, the structured cabling all at the same time, because one of those things is going to fix the issue, but you probably didn't need to do all of them. And it's important to test more than once. There's a lot of random variables involved, and if you test once, you might run into a weird process that's running on your machine, and it just chews up a lot of CPU cycles, and it'll skew your results. And the simple truth of it is taking these measurements will impact performance as well. So try and do your best to minimize that impact introduced. So my tests tonight are going to be handled by a module called RunBucket. And basically what it does is take a pair of script blocks, a control and a variation. And for the most part, the control is going to be what you would generally do in a PowerShell script, and the variation is something else you can try. A little bit more about that module. Behind the scenes, it uses posh RSjob, and that's so that we can run multiple iterations of the test cases at the same time, because we're defaulting to 100 iterations of each test case. So unless you see me specifically put dash iterations on something, it's running 100 times for each case, both the control and the variation. And the only reason I've ever decreased that is just because that particular test case takes too long to run for this sort of a format. And to address any outliers, like if I do run into random, odd situations, I disregard the slowest and the fastest results, or result, so one from each end of the spectrum. And then I grab the average, and that's what we use to decide the winner. And we also see the minimum and maximum just to get some context around it. And within that, I'm using the stopwatch.net class rather than the built-in measure commandlet. And that's because the measure commandlet actually disregards console output, which is the subject of a couple of our tests. So if we use measure command, we miss out on some of the timings. And we'll see an example of this before we start, but the results are being displayed using Adam Driscoll's PowerShell Universal Dashboard, which is a really awesome module, and if you haven't looked at it, give it a look. So, that's it for the slides for the first part of this. Let's jump over to some code. So we're going to be covering 11 topics, and those 11 concepts comprising of 16 demos, and at the end we'll have a bonus round with some comparisons between Windows PowerShell and PowerShell Core. And these demos may have unexpected results, and that's sort of the point. I've tried to pick out good examples for each of these, but do keep in mind we're dealing with a small sample set, and a lot of these increases or decreases in runtimes will vary. If you're dealing with 100 times or 1,000 times the sample set that I am, I've had to keep these quite slim to fit so many demos into less than an hour. So, before we jump into the first demo, let's have a look at that dashboard. And do let me know if you can't see the screen changing. But given I haven't seen anyone in chat mention it, I'll assume you can all see what I can see.
So far, so good,
So this
Josh.
is the dashboard. Sorry?
So far, so good. Looks great.
Awesome. So this example set of results here are literally just comparing a script that's sleeping for 5 seconds versus a script that isn't. So as you might expect, it's a hell of a lot quicker. Our control is always on the left. Our variation is always in the middle column. And red means bad, green means good. So our results are always measured in milliseconds. So the control took an average of just under 20 milliseconds, and our variation, which won, took an average of, you might as well say it was instant. And then the difference on the right is the percentage increase or decrease, so minus being faster. And in this case, it was 98% faster. So, demos. I mentioned output to the console, so let's have a look at that first. Most of my demos I've tried to keep the output of these scripts identical, so you end up with the same objects or the same output. This is the only one that varies from that, just to drive the point home. So our control is running getChildItem on my drivers directory on my machine. And as you would expect, when you run this command, it outputs the listing of files to the console. The variation being assigning that to a variable. Now, obviously, or usually, that's how you do it anyway, but it's a good example for how outputting something to the console does slow things down. So let's, and that did work. Let's rerun it. Sorry, this one's nice and quick, so we should be back to the dashboard in a second. Watching down there. There we go. So, unfortunately, the timings on this one are pretty tight. As you can see, the difference here was 1.1%. Actually, let's run this one again. I have a feeling, actually. So, edit my demos on the fly. I think I've got data sitting in my data folder. So it does depend on how many files are there, whether or not you've got access to them, and no. But basically, when you're running the commands, you'll see it more than anything else. Like when output's going to the console, it's slow enough that you can sort of pick out the patterns, if not actually read what's showing. And generally, with something like this, if you assign it to a variable, it just runs instantly. But yeah, as you can see, not the case today, but we are talking literally milliseconds here, like the difference being 0.3 milliseconds. It's really easy to miss that one. But on to something that will have a measurable impact is filters. So one of the first things you learn when working with PowerShell, if you've read a Don Jones book or watched one of Snova's videos, you'll know the term filter left. And I think we all more or less accept that that's what we should do, filter the objects as close to the start of your command as possible. But I'm not sure how many people have actually ever tested that. So our control here is we're getting some events from my applications log, where the ID is a specific number, and that was created within the last hour. This one's pretty good. We're running the command and piping it directly into where object. However, getWinEvent actually has the ability to filter directly within the command itself. Yeah, good, I did actually run that. So the difference here is this command is just going to return the events that I want. This one is going to return all the events from the application log, pipe them through, deal with it in memory, and then filter out. So I end up in events with the same results. And if we look at those results, piping through to where object takes 1.3 seconds, but using the filter within the command itself is 40 milliseconds, and that being about a 97% decrease. So yeah, filtering to the left, yes, makes a difference. If the commandlet has a filter, it's worth using it rather than relying on where object. Now, to be fair, the syntax isn't always obvious, and it's not uniform across the entire set of commandlets and functions. So it pays to look at the help and look at the examples, and hopefully there's a decent example of using the filters. And in a similar vein, there's the concept of only making expensive requests once. So I call this single touch. And the control here, as an example, is we've learnt to use the filter table. That's awesome. The filter hash table. But now we want to get an event from our app events and an event from our sys events, or our system and applications. So we end up calling getWinEvent twice. Another way to do that is to use getWinEvent once, get events from both our application and our system logs at the same time, with the two IDs that we're looking for. And yes, in this instance, I've chosen IDs that only appear in the specific. So 16384 never appears in system, and 7001 never appears in application. But then to end up with the same variables at the end, app events, sys events, we're then using the where method to split them out. So we've got app events looking for application and sys events looking for system. The result of that isn't huge in this example. Where you might see decent improvements is in Active Directory. Specifically for me, it's when I'm looking for both contractors and staff. Looking in just those two OUs is a lot quicker.
Josh,
also, sorry?
A question about
sure.
using the where method. versus typing to where object. Can you talk about that for a second?
I will when we get to this one. Pipeline.
Okay, sorry.
Yeah, good eye though. But the spoiler part of that is basically that pipeline where you pipe to where object is expensive. So I'm using .where here to keep the execution times down. Otherwise you'd blow them out. Yes, so before pipelines, let's talk a little bit about verbosity. So PowerShell's great. I need to remember to run it. PowerShell's great at giving you shortcuts to get the job done. So here's an example of getting all my services that are currently running and selecting the first 5 and assigning that to the services variable. But as you can see, I'm using aliases and shortcuts throughout here. So instead of get service, I'm just specifying service. Instead of where object, I'm using a question mark and truncating parameters, and here again using select instead of select object. And of course the variation there is spelling things out. So get service, where object, select object. And the difference being, in this example, about 4 milliseconds, so we're shaving off 40%. And for such a small change, that's quite a big improvement. Now, to be fair, a lot of that is this using service here. So in PowerShell, most of your get commandlets, you can leave off the get, and it will figure out through quite a long process that you're actually calling get service. So what it's doing is, I believe, first, if you call service, it first looks for service.exe, it then looks for a function called service, it then looks for a commandlet called service, and then when it doesn't find that, it tries again with get at the start of it. So you run through a couple of iterations before finally PowerShell's figured out what you actually want. Yeah. So, on to those pipelines. And I believe my example is where object. It is, good. So in this one, I'm querying the files in my temp directory, and I want to just find all the ones where the lengths are greater than 5,000. So, piping to where object, notice I'm being verbose here, rather than just typing where, because we know that helps now. But of course, and I think it was, I don't remember if it was PowerShell 3 or PowerShell 4 that introduced the where method, which is this .where notation. But it is generally faster. So again, keep in mind we're dealing with small sample sets here, so this temp folder only has maybe 100. Let me actually check on the fly. That temp directory has, 200 files. So with 200 files, we saved roughly 30%. Now imagine if that was thousands of files, and your control with the where. Yeah, I'm seeing in chat it was introduced in PowerShell 4, but also someone mentioned PowerShell 3. Oh. The point is you've got access to it now. But yeah, imagine you're searching through a folder with thousands of files. Your control taking 30 seconds, a minute, and shaving off a third of that. Yeah. So, on to loops. So again, this touches on the whole pipeline thing, in that we are piping to for each, which is a commandlet. And again, we're querying my temp directory, and this time we're totaling up the length of all the files. The alternative to that is assigning our files to a variable and then iterating through them with the for each statement. So despite this for each and this for each looking very similar, this one's a language statement and this one's a commandlet. And generally speaking, if it's a statement of the language rather than a commandlet or a function, it's going to be a bit quicker, but also there's inherent overhead in that pipeline character. And if we check our results with this one, we've saved about 40%, dropping from 40 milliseconds to 23. Again, keeping in mind small data set and it scales out hugely. So now these are all, what we've touched on so far have been more language slash style choices, I guess. Now we get into sort of understanding what you're trying to do with your code and how you can optimize the processes you're going through. So, and this one isn't the best example, but I've left it in here because I found it really handy when I stumbled across this just before Summit. My control here is I'm grabbing my PowerShell version from the version table, and if you haven't seen that, it comes out as an object that looks something like this. And effectively, I want to see if I'm running a version that's newer than 5.1.15000. And how I had considered doing this initially was I was going to split that version on the period, so I'd end up with an array containing 5, then 1, then 15,000. And I'd go through and check the major version being the 5 against the first element, and then go down to the minor, which is the 1, and then the build. If all of those passed, it would be a true, and otherwise false. As you might expect, there's a better way to do that, and that's to cast what I'm looking for as a version object, and then I can simply go, is this greater than that? Hell of a lot simpler, and quite a lot faster. So 40%, I mean, yes, we've gone from 1.6 milliseconds to 0.9, so you're never going to notice that difference, but it does illustrate how knowing, like, until I found out about this, I had no idea I could cast a string as a version, and yeah, it just made that so much simpler. So a better example of this unnecessary operations topic is searching for something in a hash table. So in this example, I've got a hash table which is just... So how I generated this hash table is it's a list of all of my running processes, duplicated about 10 times with a number appended to the end so I don't end up with duplicate keys. Basically, I just wanted to end up with a fairly large hash table. And in that hash table, I'm looking for a process called a process called MMC. So how I've tried to look for that is I'm looking for I'm looking for each entry in my hash table, looking at all of the keys, checking to see if my entry matches the target that I'm looking for, MMC. If it is, I return true and I break out of my for each loop. So at the point it finds it, it stops running the for each loop, I have my output. The variation on that is hash tables actually have a method called contains key. So if I have a target, I can just go, hey, is this in the hash table? And unfortunately, when it searched for it, it must have found it like really quickly. Let's try changing that to a 6. So here's the thing. If it finds, because it breaks out, If it finds it right away, which seems to be a random chance, whatever. If it finds it right away, it will break out almost as quick, if not quicker, than the method. But the method will always be pretty quick. In fact, if you look at the maximums on the control, actually, something's not right there. Control variation. Huh. As I said, some of these demos aren't going to go as I expected. There we go, that's better. So this is the result I was getting consistently when I was running through these prior to today. So I expected this to be about a third quicker. So 15 milliseconds compared to 10. But as you can see, it's a bit of a luck of the draw sometimes. And on this topic of unnecessary operations, I've got a third example. And this one should be pretty good. Fingers crossed. So in this example, I'm looking for some text in a bunch of text files. So I'm getting all my text files from the temp directory and filtering so I only get text files because that directory has Word documents, PowerPoints, all sorts in it. I'm looking for the string Josh, and how I would have normally done this is I pipe my text files to get content, so I'm loading in the content from each text file, and then from that content I'm selecting the string. However, you don't actually need to get the content. Select string will take a file and read it in a lot quicker. So right off the bat, we've dropped one function, we've dropped one pipe, and the difference is a lot. So we've shaved off about 2 whole seconds, totaling about 80%. So yeah, going from 2.5 seconds using the get content, get content, and trimming it down to half a second, which, if I remember correctly, this is the directory with 200 odd files. So yeah, again, if you're dealing with thousands of files, expect a substantial speed up. And again, this is knowing a bit more about the language, reading the help documentation, because on the surface it makes sense. You get your text files, you read in the content from them, and then you search through the content. Knowing that select string handles a lot of that for you is something you only know when you know it. Yeah. And a lot of the speed increases we've seen so far is because we're using the features of PowerShell that make PowerShell easy to use. So as you get more and more help using your system to do a task, it's abstracting away the lower level stuff from you, but that abstraction has some overhead associated with it. So as a pretty simple example, this for each loop calls the new GUID commandlet 1,000 times. So the output of this example is we end up with 1,000 GUID objects. But another way of getting exactly the same output is the GUID.NET class. And again, 1,000 GUIDs, but that's a commandlet, and this is coming directly out of .NET. And this is probably one of the biggest speed ups we'll see through all of these demos, being basically 97%. But the speed increase you get going from that to that. Well, I guess, so you get the speed increase, but you get rid of some of the friendliness of PowerShell. So this, discoverable, help files, all that jazz. This you need, well, for starters you need to know about it. 2, you might need to go off to MSDN and read the documentation about the GUID class. Or you find a decent blog article that happens to mention it. But yeah, it's one of those things where eventually you start going, I wonder if there's a way to do this in .NET, or you happen to come from C# or something similar and just know about them anyway. And to really drive that home though, this example here, we're generating 1,000 paths. So I'm using join path to create, basically it'll be $data / a number, and we'll end up with 1,000 of those. And we're using the join path commandlet. And this is something I didn't know about until is it Dev Black Ops on Twitter tweeted out about it. But there's an io.path class which you can use to combine elements of a path. So the output of these are exactly the same. And the difference is, again, 97%. Although at this scale, again, you're already dealing with sub-second times. You're just making it even sub-secondier. But again, it just shows not relying on that abstraction can dramatically increase performance. And I guess along the same vein, we can start looking at collections. So you'll often see collections established like this. So you've got a variable with an empty collection. And all we're doing here is using the random class to generate 1,000 random numbers. And each random number we're using plus equals to add it to the collection. But that's, as you might expect, a little bit expensive. And my preferred way of actually dealing with this is using specifically array lists and calling the add method on them. And you'll notice I've got null equals at the start. We'll cover that in these demo number 10, or topic number 10, I guess it technically is. But basically this add method outputs the index of the collection that you've just added to. So the first item you add, it outputs 0, then 1, then 2. And to keep them the same, I don't want to see that output.
Hey, Josh, we got a question in the room.
Yeah, sure.
So my question is, if you go to use the .NET Framework syntax, is there any benefit in regards to, or is there anything we should be aware of in regards to garbage collection and so forth?
I've not run into having to do it myself, but in my day job, I don't really ever run into issues where I'm pushing my system at all. So I'm fairly, I guess you could say, wasteful. I run my code, I close it, I forget about it, and it's out of sight, out of mind. So I guess the short answer is no, unless you specifically need to, like if you run into something where you have to implement your own garbage collection or, you know, memory management or anything sort of above my pay grade.
Okay. Well, the only reason I asked is because I wrote a script not too long ago using like WinSCP, and in the end, you know, they used the dispose method in regards to, you know, I guess, putting the class to garbage collection. So I don't see it too often, but I was just curious if, you know.
I guess somewhere where you will, I mean, it's not actually garbage collection, strictly speaking, but if you're using COM objects, you would want, like if you're launching Word from PowerShell, you'd want to close that Word instance so you don't end up locking files and anything weird like that happening. But that's, yeah.
Thank you. Josh? Josh?
Yes?
Did you also look at alternative other methods for discarding or ignoring the result other than a null variable that you assign to it?
Yes. So we'll cover a couple of them in a demo or two.
Okay.
Yeah. I mean, I think at this point you'd probably guess where it's going, like out null being slower than assigning to null, and then there's also casting as void and redirecting to null and all of that. But yeah.
Right. Okay. Thanks.
No problem.
Another thing I like about array lists is that you can also remove entries that it's the table after you've created it. So I was usually when I create an array, it's static array, so after you've added something to it, it's harder. So.
And it's got reverse.
Yeah, it does.
Yes. Yeah, there's a lot of benefits to using them other than just the speed of assigning to them.
Array list is on. I know it's got array. It still lets me go faster, but you have to know.
Cool.
Right. So I don't actually remember if we looked at the results of this one. Oh yeah, that's right. We were about 98% quicker. And of course, when you start talking about array lists and that, you end up hearing... So array lists are what I like to use for my collections. So in this example, we're going to use array lists again, and we'll compare it against another way of creating your collections, which is, why bother initializing it at all? Why don't you just assign the output of your for each to a variable? And I don't remember if this is one that is technically faster. Well, 0 milliseconds. Let's run it again. But even if it is, in that case, well, 0.2 milliseconds between them. Even if it is faster, I just prefer using the array lists because, yeah, you end up with those other methods we were just talking about. And yeah, I like the control of being able to specifically add something, and yeah. So call it personal preference. The same reason I assign to null, I guess, is because I prefer this notation to the other options, and it's faster than out null, which is where we go next.
We got another question in the room,
Yeah,
Mr. Josh.
sure.
So I'm seeing that in your array list you're using the new object. How come you didn't initialize it doing the : new or to a collection?
Well, actually, so I guess the alternative syntax here, and I'll do it on this one so I don't muck up the that demo. So I just have a habit of using the new object commandlet for no other reason than it's what I prefer. But yeah, so we could go new like that as well. Again, personal preference. I imagine that would be faster, just because you're not using the new object commandlet.
Okay, thank you.
But yeah, so unlike this here where you're calling it 1,000 times, when you're calling it once, I think the benefit of using the method itself is probably not going to be as big. run this one? I did. So yeah, we mentioned how I had null equals in the previous example. So I guess let's have a look at why. So this is my array list example again, but this time I'm piping to the commandlet out null, which looks clean and readable and makes sense. But as you would expect at this point, we've got a pipeline, we've got a commandlet, it's going to be slower. So we'll compare out null to assigning to null. Oh, my dashboard's not liking me today, is it? So I'll rerun that example. There we go. And again, we're dealing in the 98%-ish. Going from 0.1 seconds down to 2 milliseconds. So I mean, at this point, it's not going to be a shocker that out nulls dramatically slower. Again, pipeline, commandlet. But let's have a look at the alternative. So we've got null equals, well, one of the alternatives, and that's casting to void. This one, in fact, we'll run this one twice, just to show redirection as well. So technically, and this has been true most times I've run this, technically casting to void is quicker. But I prefer not to use it. And that's partly personal preference, and partly because you can't put this void at the front of everything. Whereas I haven't run into a situation where I can't assign to null. But frankly, as long as you're not piping to out null, you'll be fine. And another option is using the redirection syntax and redirecting to null. So this one and all the testing I've done, which is one of the reasons why I didn't include it, is it is slower. And I'm not entirely sure why. But yeah. So null equals, it's my go-to. Yeah, call it personal preference. Now, the last demo here is sort of the mother of all speed improvements, which is doing things in parallel. So all of these test cases have been using PoshRSjob to run all multiple test cases at once. And that's so that we're not sitting here waiting for me to like enumerate 1,000 GUIDs 1,000 times twice, or 100 times twice. So an example of this in operation is pinging a bunch of addresses out on the internet. And yes, I'm using test connection here rather than the .NET class, but that's because I need to slow it down a little bit. So in my control here, I've got a list of targets, which is Google's DNS, Cloudflare's DNS, and a random news site here in New Zealand. I'm going to iterate through each of those, and one at a time, I'm going to test the connection to it by sending 2 echo requests at it, returning true or false, or rather storing true or false, and then outputting an object that contains what I pinged, what the response was. So just thinking that through, that's going to be 5 requests, 5 hosts. It's going to do the first one, then move on to the second one, then the third one, then the fourth, and so on. And using PoshRSjob, we've got the same targets, but we'll pipe that through to startRSjob, which is going to then run all of those in parallel. So it's going to take all 5, test the connection to all of them, and I'll receive the output of that so that we end up with the same output at the end. So in theory, if I run it again and we get some actual results this time, we should see it be about 75% faster. Mathematically, it should be 80% faster if it was pure, I guess is a good word for it. But there is some overhead in spinning up those jobs. It's still running. There is some overhead in spinning those up. So you don't get a true, like, running 5 things at once doesn't just give you 1/5 of the execution time. It does, yeah. That's not good. Variation targets, yeah, that all looks right. All right, let's give this one more try. Apparently my dashboard really doesn't like me today. And if this doesn't work, just take my word for it and we'll move on to the PowerShell core part of this. As an aside, while this is running, this all of these demos were originally lined up to run in Visual Studio Code, and as I pulled up each example, the test cases run automatically. There we go. But that broke last night. So I've had to switch over to the ISE and I'm running these manually. But there you see, 73% faster. So remembering each target, I'm sending 2 echo requests. So in general, each host takes about 2 seconds. So multiplying that out over 5, you tend to get between 7 to 10 seconds per host in total when you're doing them sequentially. But when you're doing them in parallel, you get down to 2-ish seconds. And the more you do in parallel, of course, the less time it takes. So where you might actually use this is if you needed to go off to your entire fleet of desktops and look for a particular file in a particular directory. If you can do 50 desktops at once rather than one at a time, of course that's going to be a hell of a lot faster. And PoshRS job is just the module I prefer to use for it because it's worked well for me so far. So that is all of those demos, but I've got a little bit of a bonus round. So here I've got, of course, the blue console is Windows PowerShell 5.1. The black one is PowerShell Core 6.1. And I'm just going to run the same examples in each of them. So, excuse me while I copy them over. So here we're just doing our new GUID example again. But this time we're doing it 1,000 times. Sorry, 10,000. Yeah, 10,000 times rather than 1,000. And as you can see there, PowerShell Core's done that. And sorry, we don't get nice percentages this time, but we've shaved off about 1,000 milliseconds or 0.1 of a second. What I've found with PowerShell Core is it does tend to be faster, but that really only applies to larger data sets. But before we have a look at that, let's do, so this is our collections example again using the array lists. And in this case, Windows PowerShell comes in at 86 milliseconds, but PowerShell Core takes a little bit longer. So there are still things that PowerShell Core's slower at, but each version they seem to be making better and better progress on that. Technically, two more examples, but they're very related. If you look at the release notes for 6.1, they mention the speed increase in using the group object commandlet. And when I went to run this initially, I edited their example a little bit and couldn't figure out why I wasn't seeing what they were seeing. So in this case, I'm getting 1,000 random numbers and grouping them. And this was specifically one of the examples that Microsoft gave of PowerShell Core being faster. But as you can see, Windows PowerShell took 68 milliseconds. PowerShell Core took 74. And, you know, that's slower. What it ends up being is a PowerShell Core is faster with group object as long as the data set is bigger. So originally we'd done 1,000 random numbers. Now we're doing, my eyes are going wonky, 100,000 if I'm seeing that correctly. And there you can see Windows PowerShell took 20 seconds, PowerShell Core took 8. And of course, as you scale this out more and more, PowerShell Core gets more and more and more of an edge over Windows PowerShell. So I guess what the PowerShell Core thing at the moment is, try it. If you do notice something that's slower, consider opening up an issue so that it can focus in on it, if there isn't already an issue open, because that's the great thing about it being open source now. So that's all of our demos. Let's quickly go back to the slides and wrap up. So I guess the question after all of that is, are these examples a silver bullet? And as you will have expected from, or might have expected after some of those demos didn't quite work how I expected them to, the simple answer is no. And part of that is, while some of these methods are going to be faster, you might run into memory consumption or CPU bottlenecks, depending on specifically what you're working on, how big your data sets are, etc. Implementing some of these without fully understanding what you're changing might break a working script, and we'll touch on what to do about that in the next slide. And your environment's a snowflake. So I know what works for me in my environment, on my servers, on my desktops, and that might not follow through on your environment. Now, I guess the takeaways from all of this, don't make assumptions, or as in the picture, don't be a stick in the mud. Don't be afraid to try new things, like, just because you've done something one way forever, don't hesitate to try something else. Measure twice. As you saw, I had to run a couple of those tests multiple times, and every time I ran them, I got something different. And on some of them, it was so tight that who won swapped. And revisit, especially at the moment if you're looking at PowerShell Core. When PowerShell Core 6.2 comes out, revisit your tests. Especially, and potentially Windows updates might change something. Going to Server 2019 over 2016 might change something. Keep your tests handy, rerun them every once in a while, just see if the landscape's changed at all. And worry about optimization after it's working. So don't go into unless you know exactly how you implement something. So like, for instance, for me, I always use array lists. I always assign to null there are certain things I always do, but if it's not your standard, worry about getting your script working first and then optimize it, if that's even what you're looking for. Nobody's saying you have to have fast scripts. And a big thing is test your code. If you've got pester tests for your code, you make a breaking change trying to optimize it, you should know pretty quickly. And because you're only changing one thing at once, you should know what broke it. And especially if you're working out of source control, you should be able to roll it back pretty quickly too. So that's the end of the slides. That bit.ly link at the moment doesn't go anywhere. I still need to send all of these demos and slides through to Mike to get them up on GitHub. But this bit.ly link will go to wherever they end up stored. And if you've got any questions, feel free to hit me up on Twitter.
Time for questions? Shoot.
Yeah.
Josh, you have time? You have time for
questions?
Yeah,
go for it.
I was wondering how you were or where you were calculating the average. What method were you using to calculate it?
So that average is coming from measure object. So what's coming out of the stopwatch is I'm getting the elapsed milliseconds, and I just get a collection of 100 numbers. Then I whip off the smallest one and the biggest one, and then pass it through to measure object and get the minimum, maximum, and average out of that.
Okay. Have you considered using the median as your preferred value rather than the average? Because even lobbing off the highest or the lowest can still give you some skewed statistics if you've had several system weights or something like that during. So have you considered the median?
I hadn't, but now that you've brought it up, I'm going to.
And even in the worst case, the third quartile at the 75% position can also be very reliable. You kind of have to go out of your way to get to it, but I found it to be a very reliable metric when doing performance reporting and testing. So that was my question.
Awesome.
Any other questions, guys? No? Cool. Awesome. Yeah. First off, let me say thank you very much for helping us out and for rearranging your day. I know you
no problem.
Appreciate all that. So, are you going to be at Summit this year?
No. Fortunately, it's quite a long journey.
Yeah, I can imagine.
Yeah. I'm thinking every 2 years, hopefully.
Okay. Well, we super appreciate you talking for us tonight. We had the mic muted before. Your humor was well received here. Lots of chuckles in the room. You just didn't get to hear it.
Yeah, it's a little bit different trying to make those jokes in a room full of people versus online, but
Hey, let me ask you one question. If you had to give like a soundbite takeaway of all the things that you showed tonight, what's the one thing that you would press upon people, the easiest change they could make that makes an improvement?
Ooh.
Get rid of the aliases?
Well, honestly, it's not the biggest improvement, but yeah, write verbose code, because even if it doesn't give you a speed increase in terms of execution time, it's going to make your code so much easier to read. And in turn, that'll speed up being able to read and troubleshoot it in the future.
All right. Well, I will let you go. Thank you again, once again, buddy.
Awesome. Thank you. Have a good one.
All right. Have a good night.